So today we're going to look at what happens when we push things, and we're pushing them in a slightly downward motion, very similar to when we pull things upward, but just a few little changes in our free body diagrams. This happens more often than we think. Take, for example, this box. I am now pushing on this box at a downward angle. I'm just leaning on it, but the box isn't moving. That means that the force of friction must be pushing it back towards me, preventing it from moving. I could push it a little harder, and now it's starting to slide. So I had to overcome the static friction to make that happen. But I'm pushing downward, and I'm pushing over. Similar to our previous problems, we need to break my arm vector into its component vectors and see if we can solve the problem. Start. So here's an example. I've got this 25 kilogram object sitting on my workbench, and I know that there's a force of gravity pulling it downwards. And we can easily find that force of gravity at being 245.25 newtons, because you just take the mass multiplied by 9.81. What else do we have? I know that it is accelerating at 1.93 meters per second squared. And since I know that my force is mass times acceleration, I can find that my force is 48.25 newtons. And this really is my F net, my overall acceleration. So I've used this number here. Okay, let's take a look at our angle. My angle of depression. So the angle of depression is this angle right here, which is 43 degrees. Okay. We could also see that through our rules of internal angles, that is, internal angles of parallel lines, that matches this angle here. But what I can easily do is I can draw a triangle. There's a FA, should give myself a little more room. This is my FA in the X direction, and I have this, which is my FA in my Y direction. And I know that this force vector here is 85 newtons. I have a right angle here. So what do we do next? Well, I think I'm going to explore this triangle. So once again, we had a force vector here of 85 newtons with a right angle here. And this is 43. Oops, not that angle. This is 43 degrees in here. Okay, so I'm going to label this triangle. This is my opposite side, which I'm going to call FA in the Y direction. This is my adjacent side, which is my FA in my X direction. And this is just simply my applied force of 85 newtons. We know that our opposite, which is our FAY, divided by our hypotenuse, is our sine of theta. We also know that our adjacent divided by our hypotenuse is my cosine of theta. So that's pretty good. So now what we can do is we can quickly and easily find our FAY is FA times sine theta. And I'll finish that one off. So our FA in the Y direction would be our 85 newtons times the sine of 43 degrees. And that equals 57.97 newtons. So that's our FA, our applied force in the y direction. Our FA in the x direction is the applied force times the cosine of the angle. And that's going to equal 85 newtons times the cosine of 43 degrees. So our force applied in the x direction is 62.17 newtons. Okay, so what does that mean in terms of our free body diagram? Well, what that's telling us is that we have an applied force moving in this direction because we have some friction moving in the opposite direction. And we know that we have a net force of 48. So if this is 62, we can figure out our frictional force. So our F net is our applied force in the x direction, take away our frictional force. From that, we can find that our force of friction is the FAX, take away my F net. So 62.17 newtons subtract 48.25 newtons gives me my frictional force, and that's 13.92 newtons. And that's in the left direction. If we want to get that written in down here, it's going to the left. Now, our force, our normal force. Let's think about this for a second. We had a force of gravity pulling down, and it was 245 newtons. 0.25. We have a normal force pushing up, but we then found that we also have on the same spot, I'm going to make that a little shorter because it was only, our y value was 57.97, so it should be a little shorter. There we go. Our FAY 57.97. Okay. So we can easily see by drawing this piece of the free body diagram that the normal force will be equivalent, but in opposite direction to the FA in the y direction plus the force of gravity. So the Fn will be equal to this 58 plus 245. That's going to equal 303.22 newtons. So if we want to find the coefficient of friction, we can simply apply that into our formula. Our FF was 13.92. Our Fn was 303, which gives us a very small coefficient of friction, 0.0459.